Hey everybody, so we're going to be talking about measuring angles today. It is going to take up both of the pages that you see here, and I'm going to be using a lot of colors. I'm highly recommending it. We're going to be talking about angle parts, the types of angles, postulates, and bisecting lines. So first off, for my angle parts, I'm going to go ahead and draw an angle here. And I know this is super cool. I love using this because it just corrects all of my pretty little arrows into triangles. All right, and then I'm also going to label my points. I'm going to put A, B, and C here. All right, the first way that we're going to do is we're going to be talking about angle names. All right, you can write this as, I'm going to go ahead and rewrite this just so you guys can color code it a little bit better. And we're going to use green. I'm using green. You can write it as angle A, or if there's a number here, you can label it as angle 1. Now the number will be given to you. It's not the same thing as a degree if they write the degree there. You can also write it as angle BAC or angle CAB. Now notice the middle letter. That's the vertex of the angle. So I want you to write this note down, and then we're going to highlight it. When using 3 letters, the middle letter is the vertex. And we're going to be using our other color here and label our vertex, which is point A. And we're going to go ahead and again highlight this out. This is super important when you're writing this. All right, next we're going to be talking about the sides of an angle. You'll notice there are 2 rays coming from that vertex that are making this angle. And it's rays AB and ray AC. Now remember, if you're on the computer, you can write out the word ray. Notice that the first letter of the ray is the vertex. This is super important when you're notating which are the sides of an angle. And again, notice my color coding here. So I'm actually going to go ahead and put a box around vertex so you remember that this is the vertex. It's point A. Next, if they ever give you the measure of an angle, say this angle measures 40 degrees, they'll write it out for you and give that to you. And the way you would write that is that measure, the M, angle, and the way you write it is kind of like a less than, but it's got a flat bottom right here. And it's the measure of angle A equals 40 degrees. It is super, super duper important you write this degree symbol. If we were in person, if you don't write it, I would take points off. And most geometry teachers will. All right, so sometimes if you've got a congruent angle, and something that you can do, sorry, is that you can also put the degrees on there if you can't type out the degree symbol. If you've got congruent angles, say you've got these 2 right here. And you know what? I'm going to use A and J, Ash and Jax. And notice that there are lines in the middle. Just like our congruency symbols that we had for our line segments, this one line means that angle A is congruent to angle B. And in this case, angle J, because I just forgot that I changed the letters. All right, I'm going to draw a line because now we're going to go and do our next section, which is types of angles. All right, and I'm going to be using different colors for each of these. Make sure you highlight this top part just so it sticks out for you. All right, the first one is a cute angle because it's so cute, because it's so tiny. But no, really. This is an angle with the measure between 0 degrees and 90 degrees. So if we're going to draw our diagram right here, and I'm going to do it to the side. All right, and I want you to be as close to this as possible, but it doesn't have to be perfect. Not everything is drawn to scale in geometry. Your x right here, that x degrees, it's going to be between 0 and 90. It means it has to be greater than 0, but less than 90. Right, I'm highlighting these. If you want to underline it because you might not have matching color highlighters, then go for it, do that. But as long as it sticks out for you, so it's easier for your brain. These are basic note-taking skills. We're going to go on to right angle. Right, and these are going to be exactly like this. So this one has to be kind of perfect. And I'm going to put an angle, angle measuring. I'm going to do some surgery real quick, sorry. Measuring exactly 90 degrees. So your X degrees right here, you're going to see this symbol. That square right there means that it's a right angle, and it means it's exactly 90 degrees. That X is 90. Oops. And that part right there is important, so highlight it, underline it, whatever you're choosing to do. Next up, we've got our obtuse angle, and you'll notice that I'm writing it super thick, and that's because an obtuse angle means it's one of our bigger ones. So it's an angle with a measure between 90 degrees and 180 degrees. And you'll notice I left a lot of room because our diagram is going to be huge. It's going to be obtuse. And again, it does not necessarily need to be drawn to scale for this one. And most of the time it won't be. We're going to put our X degrees there, and it means that X has to be between 90 and 80, which means X is greater than 90 but less than 180. The only thing that is 90 degrees, it will be classified as a right angle. Not acute, not obtuse, just right. Kind of like Goldilocks. This next one is going to be straight angle. And you'll notice it says between 90 and 80, 90 and 180, sorry. The straight angle is going to be exactly 180. So I'm drawing a straight line, and I'm going to go ahead and put the vertex right here. And it's an angle with that measures exactly 180 degrees. So make sure you write that down, and you're going to go ahead and highlight whatever you need to and write this down with that color. All right, so next, we are going to go ahead and move on to our postulates. We're done with the angle parts and the angle types. So we're going to write our postulates, and I want you to give as much room as possible for this. So actually, I'm going to go ahead and write postulates on the first line. All right, so this is a lot to write, and I know it's going to be a lot of words. This is the protractor postulate, and it's slightly confusing, but we're just going to have to work it out together, and you'll see what it really means. So let's copy this down, and it's going to be consider ray OB and point A on one side of ray OB. Every ray of the form, ray OA can be paired 1-to-1 with the real number, sorry, I don't have room, from 0 to 180. Sorry, 0 degrees to 180 degrees. And we're going to go ahead and highlight the important parts here. It's one side ray paired in 0 to 180 degrees. Oh, sorry, I forgot that degree symbol. All right, so let's draw a picture, and we're going to work through it because this is a lot of words. Pretty much, if you're given an angle, say you're given this angle, angle AOB, you can connect it to a straight line, and figure out the difference. So say it's 40 degrees to that straight line. You can figure out that difference and then figure out what the measure of angle AOB is, because it can add up to be that total straight line. So again, notice that middle letter, that's our vertex. That O is our vertex, which is why I've mentioned that. So it's going to be the absolute value of 180, a straight line, minus this 40 degrees that's on the outside. They're going to give this to you. You don't have to figure it out. And then that's going to be the absolute value of 140, which is, well, just 140 degrees. So the measure of angle AOB is 140 degrees. And you can label it as such on your graph. Now, this next one, it's not going to be as much to write, and this is going to be the angle addition postulate. I'm going to go ahead and highlight this, and I'm going to use the green just so it sticks out a little bit. I'm drawing my symbol here first, my lines. So I've got angles, and I've got these points. I'm going to put points A, B, C in that vertex of O. If point B is in the interior, of angle AOC, meaning it's on the inside of this entire angle AOC, remember that vertex, then the measure of angle AOB, which is this one right here, plus the measure of angle BOC, this other part right here, is going to equal this entire thing of AOC. And that makes sense, right? Two parts of a paper. If I tear a paper in half, those two halves, if I put them together, it's going to be a whole paper again. So both these parts combined will make up the entire thing. Now this next one that we're going to go off to is our bisecting lines. I'm going to draw a line so we can separate that section. Oops. There we go. So we've got bisecting lines. Now you remember that bi means two, and that's what that prefix means. So we're splitting it, sect. We're splitting it into two parts, and that's what that line's going to do, and it's going to do two congruent parts. Okay, so in the figure, raise BA and BC. And let me go ahead and draw this picture first. And I think I'm missing a line. Hold on. There we go. Okay, so I'm going to label my points A, B, and C. And then we're going to go E, F, and H. All right, and this is going to be given to you as part of your graph. And that just means that these two lines, these two angles are congruent to each other. So congruent, angle ABE and EBF are congruent. And let's see what they're giving us. In the figure, ray BA and BC are opposite rays. Well, we know that because BA and BC, they're parts of the line, and they're using that vertex as their first point, that end point, to tell us that they're splitting from there. Right, and then BH bisects angle EBC. It just means it's splitting it in two, right? Not necessarily equal, but it's splitting it. Now, say if these two were equal, then we would draw these double lines right here, right? Now, that's not the case, so I don't want you to draw these double lines, but I want you to be exposed to them so that you know that in this case, all of EBH is congruent to angle HBC. All right. Again, that's only if they were congruent, but they're not. This is just a bisection. It's splitting it into two. not necessarily congruent, but just 2. Right? They're also going to give us that the measure of angle ABF is 7x minus 24, and that the measure of angle ABE is 2x. They're asking us to find the measure of angle EBF. So I want you to go ahead and highlight this so you know what you're looking for. Sometimes you get too solve happy. I'm so glad you know your algebra, but this is what you're looking for, this tiny little angle here. All right. They've given us that entire part of ABF, and they've given us this tiny part. But you remember these 2 lines right here? That meant that they were congruent. So I'm going to write this out even, that angle ABE is congruent to angle EBF. That's important information, for us to know. All right, so what that means is, though, that if we have 2 of angle ABE, that it would equal the entire thing of ABF, because 2 of those, they're both congruent and they make up the entire angle. So we know what each of these are. Angle ABE is 2x and ABF is 7x minus 24. Bring everything else down. 2 times 2x is going to get us 4x. Bring it down. And typically you would be asked to move the lighter variable, but in this case, the lighter variable is a 4x. And we want to get the x's all by themselves. So we're going to move the 7x. And it's okay if it's not the lighter variable. It's not often, but it happens. Move it on over with inverse operations. You get negative 3x equals negative 24. Divide both by negative 3. 1's out. And you're going to get x equals 8. And yay, we're done. But wait, it's asking us to find the measure of angle EBF. So we're going to have to take this number and plug it back in. All right, so what we're going to do, you'll remember that AB is the same thing as EBF. So let's find what ABE is to figure out what EBF is. We're going to drop that 8 in there, and it's going to become 2 times x, which is 2 times 8, which is 16 degrees. And because ABE is 16, and ABE and EBF are the same exact things, they're congruent, EBF is also 16 degrees. Guys, you did it. You made it through this marathon. Congratulations.